I'm going to show you guys how to solve an absolute value inequality, but first I wanted to remind you how to solve an absolute value problem. So in this one, we've got the absolute value of 3x minus 81 equals 6x. So when we go to solve, we'll have 3x minus 81 equals 6x, but we have to do it twice because the other option is 3x minus 81 equals negative 6x. So we're actually going to solve both the red and the blue. To do this, we got to get like terms on the same side. So I'm going to go ahead and subtract 3x here so I can have my like terms together. I've got negative 81 equaling 3x. I'll go ahead and divide both sides by 3 and I find out that x equals negative 27 when I solve this. But I need to check and make sure that that one works. So I'll come over to my calculator and I'm going to type in negative 27 and then I'll go control bar x and store it for x, and then I'm going to check it. So I plug it right back into the original equation. So I'll put the absolute value of 3x minus 81, and then I'm going to set that equal to 6x. And that's false. So when I come over here, I know that this does not work. So I would actually call this an extraneous answer. Now, for time's sake, I'm just going to say extra. All right, so let's go ahead and look at the blue and see if it'll work. Again, I've got to get my like terms together, so I'll go ahead and subtract my 3x over. Negative 81 equals negative 9x. To get x by itself, I'll divide both sides by negative 9, and I'm going to find out that x equals 9. So let's go ahead and see if that is a true statement or not, if that works. So I'll go ahead and say store 9 in for x. And then I'll come up here and pull my equation and hit enter, and that's a true statement. So this one is true, so I do know that it works. So that's just a quick reminder on how we solve absolute values. When I come down here, I wanted to show you guys how to graph an inequality, like kind of refresh your mind on that. Now, realize that I'm actually not working with an absolute value. There are no absolute value bars on this one. So I'm just going to go ahead and solve this linear inequality right here. So first thing I need to do is work on getting the x by itself. So I'll need to move that 13 across. When I do, I get negative 2x is greater than 84. To get x all by itself, I need to divide by negative 2. I'll divide this side by negative 2 so that these will cancel. The reason I really wanted to do this one was because I want to remind you that when you divide by a negative, your inequality sign switches. It flips. So no longer was it greater than, it's now less than. So I've got 84 divided by negative 2, which is negative 42. And I'll graph that on a number line. So I'm just going to pretend here's negative 42. Because this is a less than sign, not a less than or equal to, it's an open circle, and because it points to the left, or because I'm shading everything less than negative 42, I'm going to shade to the left. So that's how I graph a linear inequality. So now I'm going to combine some ideas. I'm going to combine absolute values and how I solved for that, and inequalities right here. So when I solve my absolute value inequality, first thing I have to do is actually get my absolute value bars all by themselves. So I'll get subtract 15 from both sides so that this will cancel, and I'm left with 4 minus x is greater than 6. So just like I did when I was solving absolute values before, I'm going to rewrite this to try to solve, and it'll be 4 minus x is greater than 6. I actually have to do it twice because it's absolute values. So my other one's going to be 4 minus x is less than negative 6. If you change the sign of the back number, if you will, I have to flip my inequality sign. So I'll go ahead and solve both. So I'm going to move this 4 across. And I get negative x is greater than 6 minus 4, which is 2. Negative x, I'll have to divide by negative 1. And so I find my answer is going to be x. When you divide by a negative, don't forget you have to switch that inequality sign. So I'm going to say is less than -2. That's one of my inequalities that I'll be graphing in a second. I don't graph it immediately because I don't know what the answer is going to be to this one, and I want my numbers to be in numerical order on my number line. So I'll go ahead and solve here so I can see what that is. I'll subtract 4 from both sides and get -x is less than -10. I'll divide both sides by a -1. When you divide by a negative, don't forget you flip your inequality. So now I've got x is greater than 10. On my number line, -2 would go here and 10 would go here, just numerically on a number line. When I think about -2 and graphing that one, it's going to be an open circle because it's a less than sign, and it's going to shade to the left or to the numbers that are less than -2. When I graph at 10, it's going to be an open circle as well because it's a greater than sign, not greater than or equal to, and it's going to shade to the right or to numbers greater than 10. So there's my answer for example 1. If I were to write this out, I would have to write it in interval notation. So if I were to tell you it just in general, I would say -infinity to -2 in union with 10 to infinity. All right, so let me go ahead and delete this and move my screen up. Oops. Let's look at example 2. I do need to get my absolute value bars all by themselves, so I'll go ahead and move my 10 across. And so I'm going to be left with x, absolute value of x plus 4 is greater than 8. So I'm going to need to solve this twice. One of them is going to be x plus 4 is greater than 8, and my other one is going to be x plus, I didn't know if I could make it work. X plus 4 is less than -8. I flipped my inequality because I made my 8 negative. To solve, we'll just go ahead and move our 4 over so that these cancel. And x is going to be greater than 4. I'll leave that alone for just a second so I can see what my other solution is. Again, I'll subtract 4 from both sides so that these will cancel. And I find out that x is less than -12. On the number line, -12 would go on this side, and 4 would go here. When I think about graphing x is less than -12, I see that it will be an open circle, and I'm going to shade all numbers less than -12, which are going to be to the left. When I graph 4, it also will be an open circle because it's greater than, not greater than or equal to, and I will shade to the right of 4, or numbers greater than 4. If I were to write this in interval notation, I would say -infinity to -12 in union with 4 to infinity. All right. My next problem is you can try it if you like by yourself. I'm going to go ahead and solve it. So you could push pause on the video, but here I go. Again, I got to get my absolute value bars by themselves, so I'll subtract 7 from both sides so that this will cancel. And I'm left with x minus 2 is greater than or equal to -4. So when I go to solve this, I have to write it twice. X minus 2 is greater than or equal to -4. And I'll say x minus 2 is less than or equal to +4 because I changed the sign. To solve the red, I'll add 2 to both sides and get x is greater than or equal to -2. For the blue, I'll go ahead and do the same by adding 2 to both sides. However, this one says x is less than or equal to 6. When I graph this on the number line, -2 would go here, numerically, and 6 would go here. At -2, it'll be a closed circle because this is a equal to problem. This means closed. And I'm going to shade everything to the right because the arrow points right, or greater than -2, which would be all those numbers here. At 6, it'll also be a closed circle because it's equal to, and it's going to be shading all numbers to the left. So you can see that these actually cross each other, and that's my solution, is where they cross. If I rewrote this in interval notation, it would be a bracket at -2 all the way to 6 with a bracket. All right, so my next one, oops, I'll go ahead and solve this one. I need to get my absolute value bars all by themselves, so I'm going to go ahead and add 3 to both sides. These will cancel, and I'll get the absolute value of x minus 5 is greater than 4. So to solve, I'll go ahead and say x minus 5 is greater than 4, and my other one is going to be x minus 5 is less than -4. I'll add 5 across to get my like terms there, and this is going to be x is greater than 9. My next one, I'll add 5 across, and I'll see that x is less than 1. On the number line, 1 would go here, and 9 would go here. At 1, it's an open circle, and I would shade less than 1. And at 9, it's an open circle, and I would shade greater than 9. Now I'm going to show you guys how to graph, and I don't have very much time. I have like 6 minutes to do this in. So let me go ahead and show you guys how to graph. First thing that you guys want to do is that you actually want to get it equal to 0. I need one side to be 0. So in order to do that, I'm going to take this 4 and move it across. When I do that, it's actually going to look like this. So I'm going to go ahead and subtract 4 across. And I'm going to have the absolute value of x plus 3 is greater than, oh gosh, I forgot. I'm sorry. Not yet. X plus 3 minus 3 is greater than 0. Now when I have a 0, I need it to be on the left. So I'm going to go ahead and switch it and put 0 on the left. So I'm moving it all the way over here. And that means that this piece is going to have to go on this side. So x plus 3 minus 3 needed to go on this side. Now when I flip everything, guess what happens to the inequality sign? It too flips. So I'm going to go ahead and flip it. This is what I need to graph in my calculator. So I'm going to show you guys how to do that in your calculator. I definitely need to have a new document, and I need it to be a graph. When I do this, you'll notice that there is an equal sign here. If you hit the delete key and delete the equals, you can now choose what kind of inequality sign that you want. Let me look and see what kind of inequality. I want a less than sign, so I'm going to choose the less than sign, and I'm going to type in my equation, which was the absolute value of x plus 3. So I'm going to say x plus 3, and then minus 3. And when I hit enter, that's what the graph of it's going to look like. So I'm going to sketch that graph here on this graph. Now, one thing that my graph paper on my calculator didn't tell me was if this was an open inequality or a closed. And actually, because it's just greater than, not greater than or equal to, it's going to be an open line. So I'm going to go ahead and graph this, and I'm going to draw an open line. And then I'm going to shade everything below it, like my calculator showed me to do. I'm going to have to pause the video there.